Welcome to the Introduction to Panel Data workshop. This workshop is actually a continuation of our previous session where we previously discussed the methods to analyze time series data, while today our focus will be towards the panel data analysis. If I can show you the slides that we are going to use. So all right. To begin with, the panel data is actually a combination of both cross-sectional and time series data. But before that, if I can ask Puan Elizabeth, the admin for this session, shall we start the session or do we have to wait for the rest to join before we begin our workshop? Puan Elizabeth?
Ya, Dokter.
Okay, terima kasih Puan.
Okay.
So, as I mentioned just now, in this workshop, our focus will be towards panel data analysis. So this panel data is the combination of cross-sectional and time series data, where the cross-sectional is a type of data that we collect by recording the attributes for multiple entities at one point in time or without regard to differences in time. So this entity or subject can be macro or micro entities that includes individual, household, firms, industries, regions, and countries. For example, say that we collected the CGPA for all UMS students in semester 1, session 2019-2020. So this is a type of cross-sectional data because we have multiple entities. In this case, UMS student will become our subject or entity at one point in time, semester 1, session 2019-2020. Conversely, time series is a type of data collected by recording the attributes of a single entity over several time periods or multiple time periods. So these time periods can be in various frequencies. They can be hourly, they can be daily, weekly, monthly, quarterly, or annual observation. For example, say that we collected the CGPA for one UMS student. So we only have one entity from several semesters. In this case, in this instance, from semester 1, session 2019-2020, up to semester 2, session 2021-2022. So in this case, we are analyzing or collecting or gathering a time series data. So data keratan rentas adalah satu bentuk data yang dikutip di mana kita mempunyai pelbagai entiti namun hanya satu tempoh masa sahaja. Tapi bagi data siri masa, kita mempunyai satu entiti ataupun entiti tunggal namun mempunyai tempoh masa yang pelbagai. So as I mentioned before this, the panel data is a combination of both time series and cross-sectional data. The panel data can also also be referred as the longitudinal data. So it is a type of data, as you can read from the slide, it is a type of data collected by recording a characteristic of many subjects or entity over several time periods. For example, we collected the CGPA for all UMS students from semester 1, session 2019-2020, up to semester 2, session 2021-2022. So in this case, we have multiple entities and multiple time periods. So that is why we referred this example as a type of panel data. So since the panel data is a type of data that is collected or contains the observation for both time series and cross-sectional information. Thus, the information available on panel data will provide a more efficient estimate in comparison to the time series or cross-sectional data alone. Maksudnya di sini, oleh kerana data panel mempunyai kedua-dua maklumat keratan rentas dan maklumat siri masa, estimation ataupun anggaran yang diperolehi daripada analisis data panel adalah lebih cekap or more efficient compared to the two type of data that we have mentioned just now. All right. So this is an example of a panel data. So in this example, we have three entities represented by three countries: Brunei, Cambodia, and Indonesia. Apart from that, we have a number of time periods. In this case, from 1991 up to 2000 for all three countries. We also have the observation for a number of variables: tourists, number of tourist arrivals, we have the CPI, we have the gross domestic product, trade openness, as well as the exchange rate. So in this example, dalam contoh ini kita ada mempunyai maklumat keratan rentas yang pelbagai dalam tempoh masa yang banyak daripada tahun 1991 ataupun lebih daripada satu, daripada tahun 1991 hingga tahun 2000. Basically, we can group panel data analysis into two types. Kita boleh kategorikan analisis data panel kepada dua kumpulan: static panel data analysis and dynamic panel data analysis. So in a static panel data analysis, here we have a simplified equation where the dependent variable at I cross-sectional entity, or for I cross-sectional entity at T time periods, is explained by an intercept for I cross-sectional entity, a set of independent variable for I cross-sectional entity at T time periods, and an error term for I cross-sectional entity at T time periods. So when we write the equation for a panel data, we will have this subscript that shows the information for the cross-sectional entity and the information for time series. While compared to the static panel data analysis, in a dynamic panel data analysis, we have the independent variable for I cross-sectional entity at T time period that is explained by an intercept for I cross-sectional entity, lag value for the dependent variable that will become the additional independent variable. So this represent the lag value. Okay, this represent the lag value for the current value of the dependent variable. And then of course we also have a set of and the error term for I cross-sectional entity at t time periods. So the difference between static and dynamic panel data analysis is that in a dynamic panel data analysis, we include the lag value of the dependent variable as an additional independent variable. So in order to determine, of course, there are various methods that we can use to determine whether we're supposed to use static or dynamic panel data. But the simplest way is based on of the dependent variable is important in explaining the current value of the dependent variable. In that case, data analysis. Jadi, perbezaan di antara data analisis statik dan juga analisis panel data dynamic adalah nilai lag bagi pembuli ubah bersandar. Jika kita mendapati ataupun jika kita mengandaikan bahawa nilai terdahulu bagi pembuli ubah bersandar adalah penting menerangkan nilai pembuli ubah bersandar akan analisis data panel berbentuk dinamik. Tetapi tidak andaikan bahawa nilai terdahulu bagi pembuli ubah bersandar sebagai signifikan dalam mempengaruhi nilai semasa bagi pembuli ubah bersandar, maka dalam kes tersebut kita akan menggunakan panel data analysis yang berbentuk statik. So if you have any question, you can simply include or write down your question. Yeah. So I have to constantly check when I open the slides and when I presented the slides, I cannot see the, chat box. So that is why I have to constantly close my presentation and then refer to the chat box and see if we have any questions. I am sorry because sometimes you cannot hear my voice, maybe because we have internet problems. Yeah. All right. So let us now shift our attention towards static panel data analysis. There are various methods that we can use to analyze static analysis, but of course, the most common methods used can be grouped into three. They are the fixed effects model, random effects model, and the pooled OLS. So this is the simplified equation for fixed effects model, where we have the dependent variable for I cross-sectional entity at t time period that is explained by an intercept for I cross-sectional entity a set of independent, so this is a set of independent variable for intersectional items or entity at t time periods and an error term for intersectional entity at t time periods. While in a random effects model, we have the dependent variable that is explained by a common intercept, the error for between entities for I cross-sectional entity at t time periods, a set of entity at t time period, and the error term for within random effects model. We assume that the variation across entity is random and uncorrelated with the in a random effects model, we assume that the variation across entity to be random and uncorrelated with the regresses. So if we believe that the differences across entities influencing the dependent appropriate. Maksudnya, jika kita andaikan bahawa kepelbagaian terhadap entiti yang dikaji mampu mempengaruhi pemboleh ubah bersandar, maka dalam kes tersebut gunakan random effects model. So the advantage of random effects model is that we can include time invariant regresses. We can include time invariant regresses such as genders, nationality, or race, for example. So that is the advantage for random effects model compared to fixed effects model, di mana bagi random effects model, kita boleh memaksudkan, kita boleh data yang tidak mempunyai perbezaan berdasarkan tempoh masa. Sebagai contohnya, maklumat berdasarkan jantina mengenai kaum ataupun maklumat mengenai sesebuah negara, Malaysia, Indonesia sebagai contohnya. So, the variation across entities will be shown based on these what we call as a error term. Okay, it will be collected based on this error term. While in a fixed effects model, the variation across be absorbed by the sectional entity. So when we analyze the fixed effects model, random effects model, and the pool OLS, there are various diagnostic tests that we can conduct in order to identify the validity of our estimation. Model, once we run the estimation, we have to test for the existence of heteroskedasticity. because in a fixed effects model, we assume the model to be homoskedastic. That the variance across errors are non-constant across time. Apart from that, we also have to test for the cross-sectional dependence in a fixed effects model. So we assume that in a fixed effect model that the error should not be correlated across berdasarkan model fixed effects, kita perlu mengandaikan bahawa error term adalah tidak berkorelasi di antara entity yang dikaji. And then last but not least, we can also check for the normality of the error term, normality of the residuals, because in a fixed effects model, we assume that the residuals to be normally distributed. In a random effects model, on the other hand, there are various diagnostic tests that we can conduct. One of them is the Hausman test. The Hausman test is used to determine whether we're supposed to use the random effects model or the fixed effects model. So kita menggunakan Hausman test dalam membandingkan, dalam menentukan sama ada kita menggunakan model random effects ataupun model fixed effects. Apart from that, we can also conduct the Bruges Pagan test. So this is a test that we use to compare between random effects and pooled OLS. Of course, we also have to test for the cross-sectional dependence. Similar to fixed effects model, in the random effects model, we also assume that the error term to be non-correlated across entity. And we also assume, similar to fixed effects model, in a random effects model, we also assume the error term or residual to be normally distributed. In a pooled OLS, we also have quite similar assumption or diagnostic test that we have to conduct whenever we analyze the data based on pooled OLS. We also have to assume the data to be homoskedastic. And then apart from that, we also have to assume the error term to be non-serially correlated, and we assume the error term to be normally distributed as well. So these are among the concepts that we have to know in order to analyze the static panel data analysis. So I believe we can now go to the application. Okay. We can now go to the application, and in order to conduct some panel data analysis, please download and install the Gretel software in your computer or laptop, and then use the data that I have emailed before this, because we are going to use the data in order to run some analysis on static panel data. Yes, of course, our internet connection is not stable, so that is why sometimes you might not be able to hear my voice. But I hope that since we are recording the session, perhaps you can watch the session after this. Once Puan Elizabeth have uploaded the session either on our YouTube channel, if we have a YouTube channel, or perhaps on our Facebook page, on the FPEP Facebook page. I am sorry for that one. So I give you 5 minutes to download and install the Gradle, and then try to retrieve the email, or try to retrieve the data that I have emailed before this, because we are going to use it for some application on static panel data analysis. So I give you 5 minutes. Welcome back, everyone. I hope that you have installed the Gradle. Okay, good. So 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 Nur Azilawati is asking if we can send the data back because she just joined the workshop. So I am not sure if your name is listed in the email that I have sent before this, because in that email, I have attached together the data that we're supposed to use in this workshop. So Nur Azilawati, kalau kamu boleh cek semula email yang dihantar oleh Puan Nur Azia, Puan Elizabeth sebelum ini. So dalam email itu saya ada lampirkan data yang kita boleh gunakan. Because I don't know whether we can send the data through Google Meet. I'm not sure whether we can do that or not. So saya harap yang lain sudah install Gretel. So the reason why we use Gretel is because Gretel is a free software that you can download online. Kita boleh sahaja download dan install Gretel. So that is one of the reason why we use Gretel instead of various statistical software that are out there. Of course, there are various statistical software that you can also use to estimate static panel data analysis or to run static panel data estimation. But in this workshop, in this particular workshop, we are going to use the Gretel because it is available online and you can freely download it in your laptop. The name of the software is Gretel. Gretel. So software ni adalah percuma. Kita type sahaja Gretel dalam Google, kemudian kita check. If I can show you, okay, if I can show you on how to get the Gretel. All right. So simply type Gretel. I hope that you can see my screen. Okay. So simply type Gretel. Okay. So here, Gretel can be used for both Windows and Mac operating system, Mac OS. You can use Gretel for both operating system. So when you are using the Windows, you have to determine whether you are using the 32-bit or 64-bit Windows operating system. So in my case, I am using the 64-bit. Okay, most of us are using 64-bit of Windows. So you can simply download the driver and then install it in your computer. But never mind, to save time, maybe you can do some, some tutorial your own after this, okay? Once we have completed our workshop and once Puan Elizabeth have uploaded the video on the internet, on our Facebook. All right, so I can just cancel it because I have the Gradle already installed in my computer. All right. So once you install Gradle, you can open it. Okay, you can open the software. So this is the what you call as the Windows for Gretel. Yeah, if you open it, and there are various ways that we can do in order to import our file on the Gretel. But the simplest method is to drag our file, okay, on the Gretel itself. So here we have the file. We simply drag the file and then drop it on the software. And then after that, we have this spreadsheet import option. Simply click OK. I hope you can see this screen. And then here we have an information. So Gradle found one valid sheet and 8 variables with 207 observation. So we can simply close this pop-up info, and then we have another pop-up for open data. So here we have to determine whether we interpret the data as cross-sectional, time series, or panel interpretation. Since we will interpret this data as panel data, click yes. Click yes. So sorry, I have to see if we have some question. All right. So I assume that we can proceed our what you call as a tutorial on static panel data analysis. So here you have the structure of data set where we can either choose cross-sectional, time series, or panel structure. So we choose panel structure, and then after that, if I can enlarge it, and then after that, click forward. All right. So we have an additional choice whether the panel data is organized based on stack time series, stack cross sections, or we use index variable. So we use index variable instead, and then click forward. So we will have these options: panel index variable. So for the group index variable, we will choose country. Okay, we will choose country, while for the time series variable, so this is the cross-sectional variable, country, and our time series variable will be year. And then after that, we click forward. I hope you guys are still following me. So here we have to confirm the structure of our data set. So we have 9 cross-sectional units with 23 years of time periods. We click apply. All right. So in this particular tutorial, we are trying to analyze. Okay, we are trying to analyze the relationship between number of tourist arrival with a number of macroeconomic variables. So dalam tutorial ini kita akan cuba untuk mengkaji hubungan di antara jumlah diubah macroeconomy. So we have 4 selected macroeconomic variable: consumer price index to represent inflation, gross domestic product, trade openness, and the exchange rate. So we wanted to determine the influence of these macroeconomic variables towards number of tourist arrival. So kita ingin mengenal pasti pengaruh exchange rate, trade openness, GDP, and CPI terhadap jumlah kedatangan pelancong. So here we have a string table that shows our cross-sectional information. So we have 9 countries selected. So they are the ASEAN countries. We have Brunei Darussalam, Cambodia, Indonesia, Laos, Malaysia, Philippines, Singapore, Thailand, and Vietnam. And this is a panel data because we have both time series and cross-sectional information. We can simply close this. We will start with the fixed effects model. We will start with the fixed effects model. Remember that in a fixed effects model, okay, in a fixed effects model, we assume variation across entities to be constant. When we are including a time invariant variable in a fixed effects model, okay, the information for that time invariant variable by the intercept. So bila kita menggunakan ataupun bila kita memasukkan pembuli ubah yang tidak berubah, diserapkan ataupun ditunjukkan pada nilai intercept kita, pada nilai pemintas, denoted by the symbol alpha subscript I. So we will start with the fixed effects model for the tutorial. So in order to run the fixed effects model, so do you have any question before that, before we continue? Ada sebarang soalan sebelum kita mulakan tutorial kita? Kita akan mulakan dengan fixed effects model. Sebelum kita, all good. Sebelum kita masuk kepada random effects dan juga pooled OLS. Alright. So in order to run the fixed effects model, simply click the model, choose panel, and then choose fixed or random effects. So here we have an option to specify our fixed effects model. So we have to choose the dependent variable, and then we also have to include the regresses or the dependent variable. So our dependent variable will be number of tourist arrival. Okay, tourist arrival. And click this green or green CPI as one of our regresses. Click GDP, click trade, and then click or choose exchange rate as well. So remember, if you wanted to remove one of these variable as our regresses, you can simply click the red arrow here to remove the variable from our equation. Okay, but of course, in this case, we are going to include the exchange rate as well. So here we have some what you call as options, but in our case, since we are conducting the fixed effects, so we will choose the fixed effects model, and then after that, you can simply click OK. So we will click OK. I hope you guys are still following me. Saya harap saya tidak terlalu laju dan saya harap semua dapat mengikuti apa yang kita lakukan di sini dalam tutorial ni. Click OK. So here we have the result for the fixed effects model. In this fixed effects model, we have 207 observations. And then, of course, we have 4 variables, excluding the constant. Yeah, we have 4 independent macroeconomic variables. We have the key informations for each independent variables selected. We have the coefficient value, standard error, p ratio, and the p value. So in fixed effects model, random effects model, and pool OLS, our objective is to identify the value the coefficient. Okay, we have three objectives in conducting the panel data analysis, and they are to determine the coefficient value, to identify the significance level, and then to identify the sign of the coefficient. So ini adalah antara tujuan kita melakukan regresi ataupun tujuan kita data panel, yaitu untuk mengenal pasti nilai the sign ataupun petunjuk pekali serta mengenal pasti the significance of our coefficient, mengenal pasti tahap kesignifikanan pekali kita. Alright, so apart from the key information for each independent variables that we also have a number of key information for the model. So we have mean dependent variable, sum squared residual, down to Hannan-Quinn criterion. So in the Gretel, we also have the result for joint test on name regresses. Okay, kita juga ada maklumat mengenai joint test on name regresses. So this joint test on name regresses will or the joint significance of the independent variable in explaining the variable. So that is the purpose of joint test on the named regresses, to help us to determine the joint significance of the independent variables in explaining the dependent variable. And we also have the result for the test for differing group intercept in our Gretel. We also have the result for the test for differing group intercept. So before I explain to you what does it mean by joint test on name regresses and test for differing group intercept, let us at first try to look into the key information for each independent variables that we have selected. Kita lihat terlebih dahulu maklumat-maklumat penting yang kita perolehi daripada fixed effects model di sini. So here we can identify that the CPI, GDP, trade openness, and the exchange rate are individually significant in explaining the number of arrival. So pembeli ubah CPI, GDP, trade, dan juga exchange rate adalah significant secara individu dalam mempengaruhi jumlah kedatangan turis, di mana CPI is significant at 10% significance level. So we determine the significance variable based on the p value. So usually we use 1% significance level, 5% significance level, and 10% significance level. So based on the result that we obtain here, CPI is significant in explaining tourist arrival at 10% significance level, because our p value is less than 10%, while the GDP, trade openness, and the exchange rate are significant in influencing or explaining the tourist arrival at 1% significance level, since the p value is less than 0.01. We can also tell that CPI, GDP, and trade are positively related towards the independent variable because we have positive sign on the coefficients, while the exchange rate is negatively related with the number of tourist arrival because we have negative sign on the coefficient. So positive signs means when CPI, GDP, and trade increase, the number of tourist arrival will increase as well. While a negative sign here means there is an inverse relationship between exchange rate and a number of tourist arrival, where when the exchange rate increases, number of tourist arrival will decrease. All right. So now we go back into the joint test on name regresses. As I mentioned before that, let me go back box to see if we have any other question. Yes, Siti Nurbaya Ahmad asks, Doctor, one question, the significant level can be used at different levels, yeah, either 10% or 5%, yeah. You can either use 10%, we can accept up to 10% significance level. So if I can use a loose term here, significant and the chance of making a mistake. So that is a loose term. Ya, maksudnya di sini darjah significance level ataupun aras keertian di sini bermaksud kadar kemungkinan kita melakukan kesilapan dalam menolak ataupun gagal menolak hipotesis null. Okay? So we can choose up to, usually we can choose up to 10% significance level. All right. So now, joint test on name regresses. So the p-value here is less than 1. The p-value is less than 1%. Okay, when the p-value is less than 1%, so we can identify or we can conclude that the model, okay, the model are jointly significant, or the based on the group, we have a null hypothesis where the groups have a common intercept. Okay, the group have a common intercept. The test statistic based on F value is equal to 10.8608 and the p-value is less than 0.01. So since the p-value is less than 0.01, to reject the null hypothesis where the group have a common intercept. So we can conclude based on this test, we can conclude that the intercept is different across countries, and we reject the poolability of the countries selected. I repeat, since we reject the null hypothesis, we can say that the intercept is different across countries. As a single regression with just one intercept, because we have a different intercept for the countries selected. Of course, there are a number of diagnostic tests that we can conduct. One of them is the Heteroskedasticity Test, where we can choose the group-wise heteroskedasticity analysis. So here, in order to test for the diagnostic, in order to conduct the diagnostic test, click Test, click Heteroskedasticity, and choose group-wise. So we can simply close this pop-up result and straight to the summary of the heteroskedasticity testing. So the distribution free wall test for heteroskedasticity. The null hypothesis states that the units have a common error variance, where the asymptotic test statistic for chi-square is equal to 36,269.6, and the p-value based on our heteroskedasticity test is equal to 0. Remember, if the p-value is equal to 0 or less than 10%, sorry, remember, if the p-value is less than 0.1, we have to reject the null hypothesis. Yeah, if we are using 10% significance level. Yeah, so here, since p-value is equal to 0, we have to reject the null hypothesis where the units have a common error variance. In other words, we can identify that our model contain heteroskedasticity, or in other words, we can tell that the model is not homoskedastic, where the error variance are not constant across time periods. So there are various remedies that we can use to fix for heteroskedasticity. And one of them is to use a robust standard error. Because keep in mind, when we have the heteroskedasticity issue, it means that the standard error obtained in the result is not robust. So when the standard error is non-robust or non-accurate, the inferences that we made on the model will be inaccurate as well. So we can use the robust standard error in order to fix for the problem of heteroskedasticity. So that is one of the attempts that we can use to fix heteroskedasticity. But of course, it also depends on the model. It also depends on the data that we have. So apart from the heteroskedasticity, we can also test for the normality, okay, of the residual. Because keep in mind, in a fixed effects model, we assume that the so we can close the graph, and we can also close the residual distribution graph here, and then straight to the summary of the test. Test for normality of residual states that null hypothesis assume the error to be normally distributed. So the test statistic for chi-square is equal to 488.205 with p-value that is less than 0.01. So since p-value is less than 0.01, we have to reject the null hypothesis where the error term is normally distributed. In other words, we have to assume that our residuals in the model are non-normally distributed. They are not normally distributed. So another diagnostic test that we can conduct will be the autocorrelation test. We can close this pop-up result for autocorrelation and straight to the summary. So the autocorrelation is conducted based on Woolridge test for autocorrelation, where the null hypothesis states that there is no first order autocorrelation. So this is what we assume in the null hypothesis. While the alternative hypothesis, if we can explain it further, while the alternative hypothesis states that the model contains first order autocorrelation. So the test statistic based on F value is equal to 723.931, while the P value is also less than 0.01. Remember, in the autocorrelation test, we wanted to identify the non-randomness of the model. So, since the p-value here is less than 0.01, we have to reject the null hypothesis of no first order autocorrelation. In other words, we can say that our model contains first order autocorrelation. So there are various reasons, okay? There are various reasons why our model suffer from the issue of autocorrelation. And one of them is because we miss some key variables in the model. Yeah, so since we exclude these key variables in the model, the information for that variable will be absorbed by the error term. Okay, the variables are observed by the information of the missing variables will be observed by the error term that causes the error term to be correlated. So maksudnya di sini ada pelbagai perkara ataupun faktor yang menyebabkan masalah autokorelasi pada data kita. Antara perkara tersebut adalah kegagalan kita dalam memasukkan pemboleh ubah lain yang penting dalam mempengaruhi pemboleh ubah bersandar. So, oleh kerana kita tidak memasukkan pemboleh ubah tersebut dalam model yang kita anggarkan, maklumat mengenai pemboleh ubah tersebut akan diserap oleh error term, akan diserap oleh residual yang menyebabkan error term pada model kita itu berkorelasi. So, of course, there are various remedies that you can try in order to fix the issue of autocorrelation. You may try to include those significant variables that are missing in the model, or you can also try to log transform your variables. We can log transform the variables into natural logarithm in order to try to fix the issue of autocorrelation. Apart from that, we can also try to use dynamic panel data instead of instead of the static panel data. So another reason why autocorrelation happen is because we may suppose we might or we supposed to use a dynamic panel data, but on the other hand, since we are using static panel data, we experience the autocorrelation. Maksudnya di sini antara faktor lain yang boleh menyebabkan autokorelasi adalah kita sepatutnya menggunakan dynamic panel data analysis. Tetapi oleh kerana kita menggunakan static panel data analysis, model yang kita anggarkan tersebut mengalami masalah autocorrelation. So that is another reason. Or maybe instead of using a linear panel data analysis, we supposed to use the non-linear panel data analysis. Okay, maksudnya berbanding kita menggunakan analisis panel data berbentuk linear, kita mungkin sepatutnya menggunakan analisis panel data berbentuk non-linear. But we save that discussion for another session. So apart from the autocorrelation, we can also test for the cross-sectional dependence. So this is another important assumption for the fixed effects model. We close this pop-up result. So the cross-sectional dependence for Gretel is dependent test for cross-sectional dependent, or also called as Pasaran CD. So the null hypothesis states that there is no null dependence. So this is a very important assumption in text model, where are not supposed to have contemporaneous correlation in the model, where the model are not supposed to have what you call as cross-sectional, sorry, the model are not supposed to have error term that are cross-sectionally dependent. Is that Z is equal to 9.3501 with p-value that is less than 0.01. So remember that this cross-sectional dependent test is an attempt to test whether the residual are correlated across entity or not, where when the model contain contemporaneous correlation, it means that the cross-sectional dependence can lead to bias in the test results. Yeah. So in other words, when we reject the null hypothesis, just like what we have here, we can say that our model contain contemporaneous correlation. And it implies that the residues are correlated across entities. So that are among the diagnostic tests that we can conduct in order to determine the validity of our fixed effects model. So I hope you guys understand the methods or the step that we're supposed to take in order to run the fixed effects model. And we will take a break for, say, 5 minutes before we continue with the random effects model. Apologize. I am sorry if, say, I'm fast in showing you the steps to process the fixed effects model based on Gretel, because we have quite a limited time here. Yeah. But of course, if you have additional question, feel free to write or post your question on the chat box that we have in this Google Meet session. So Siti Nurbaya Ahmad asked if we can use mixed signal resolve if we have multiple independent variables. Well, ideally, we're supposed to use a uniform significance level, yeah, in order to interpret the significance of the independent variable in explaining the dependent variable. Yeah, say for example, we wanted to conclude, okay, if we can use this for example. So in order to determine whether the variables are significant or not in explaining the dependent variable, in order to determine whether the independent variables are significant or not in explaining the dependent variable, you can either choose 10% significance level, 5% significance level, or 10% significance level, for example. But of course, when you conclude the relationship for each individual independent variable, with the dependent variable, you can explain based on the significance level for each of the independent variable. CPI. So this CPI is significant at 10% significance level in explaining the number of tourist arrival, while the GDP, trade and exchange rate are significant at 1% significance level. So when we try to conclude the significance for each independent variable, we will use the significance level for each independent variable, of course. But we cannot use 10% level and then 5% level, 10 or 1% level. We cannot use the significance level in order to reject or fail to reject the significance for individual independent variable. For example, since we say that GDP, trade openness, and exchange rate are significant at 1% significance level, while CPI is not significant at 1% significance level. Ideally, we better use a uniform significance level in the model. Okay, so if this significant at 10%, we can also say that this are significant at 1% significance. To significance level, we use 5% significance level across all the independent variables. Yeah, we use 5% significance level. So if we have an independent variable that is 10% significance level, we conclude that variable to be insignificant at 5% significance level. So we cannot use different significance level in order to reject or fail to reject the hypothesis of a significant relationship between independent and the dependent variable. So I hope I clarified the question, that particular question. So we try to take a break for 5 minutes. And we will continue at 10:25. So we continue our session. So if I can re-explain what I mentioned before this, before we take our break just now. So when we explain the significance of the dependent variables, preferably we use a standardized significance level, a common significance level. Say we choose 10% level, then we conclude whether the variables are significant based on that particular percentage. So that is why people or researchers commonly choose a higher level of significance so that we will not easily reject the relationship between variables tested, because when we choose 1% significance level on the other hand, then we have to reject the significance for variable that have a higher significance level, 5% or 10% level. Yeah. So we continue our discussion on panel data analysis or static panel data analysis by conducting the random effects model. So in Gretel, random effects model is determined or estimated based on generalized least square, or also known as the GLS. So in order to run the random effects model, in order to run or estimate the random effects model, we choose model similar to fixed effects model and then choose panel. Here we choose fixed or random effects. We choose fixed or random effects. Click that option, and then here we have to specify the model. Of course, our dependent variable will be the number of tourist arrival, and just like previous estimation, we will also use CPI, GDP, trade, and the exchange rate as our regressor, excluding the constant term. Okay, we also include the constant term as our regressor. So here, instead of the fixed effects, we choose random effects. We choose random effects, and we have a number of options to estimate the error variance, either Swami, Aurora, Baltagi-Chang, or Love. So it depends on the assumption that you have in your model. But on this session, we are going to use the Swami Aurora approach to estimate the error variance. So click OK. Click OK. Here we have the results for the random effects model. Of course, we have 9 cross-sectional units because we have 9 countries. Okay. We have 9 countries. We have 23 years of time period, and our dependent variable is the number of tourist arrival. So we also have a number of key information for each regresses that we have selected. We have the coefficient value for the regresses, standard error, z value, and the p value. So from the result, we can identify that CPI is not significant at 10% level, while GDP and exchange rate are significant at 5% significance level, since p-value is less than 0.05 or between 0.05 and 0.01, while the trade openness, on the other hand, is significant in explaining the number of tourist arrival at 1% significance level, since the p-value is less than 0.01. 0, 1. So, of course, apart from the significance level, we can also determine the value of the coefficient and the sign of the coefficient. Kita boleh menentukan nilai bagi pekali serta petunjuk bagi pekali untuk setiap pemboleh ubah, where we can identify that GDP and trade openness are positively related to tourist arrival, while exchange rate is negatively related with number of tourist arrival. Remember, when they are positively related, it means that when the independent variable increases, the dependent variable will follow in a similar direction, while a negative relationship imply an inverse association or relationship between the variables, where when the dependent variable when the independent variable increases, the dependent variable will decrease. It will move in the opposite direction. Of course, we also have some key information for the model, for our random effects model. Kita ada beberapa maklumat penting yang boleh dirujuk bagi model random effects kita. Apart from that, here we have the between variance, within variance, theta used for quasi-demeaning, and the correlation coefficient. So same goes to the fixed effects model. We also have the results for joint test on the name regresses. So kita juga ada hasil keputusan untuk menentukan sama ada pemboleh ubah kita secara bersama mampu mempengaruhi jumlah kedatangan pelancong ataupun tidak. So as I mentioned before, this joint test on name regresses is used to determine the joint significance of our independent variable in explaining the dependent variable. We also have the Bruges Pagan test. So this Bruges Pagan test is used to compare between between random effects and pooled OLS. So the Bruges Pagan test has a null hypothesis that the variance of the unit specific error is equal to 0. So null hypothesis states that the variance of the unit specific error is equal to 0. Here, the asymptotic test statistic for chi-square or based on chi-square is equal to 104.575 and p-value is less than 1%. It is less than 0.01. So since p-value is less than 0.01, we can safely reject the null hypothesis and conclude that it is evident for the significant differences across entity. Okay, it is evident.
Doctor, sorry,
Yes,
you haven't clicked the present now. We cannot see your screen.
I
Sorry.
see. Okay. Thank you very much for reminding me. Yeah, so that
Okay.
is the importance of informing me if you have a situation, because for example, like in this case, I forgot to click the presentation. So I presented by my own in that case. Okay, thank you very much, Haniza, Roxanne. So I am sorry for that one. All right. So I have to, run the test again, but never mind, because we still have some time. All right. Again, I am sorry for that one. Yeah. All right. So in order to run the random effects model, we choose model, choose panel data, and choose fixed or random effects. Yeah, I hope that you can see the screen. Fixed or random effects. Here, choose number of tourist arrival as the dependent variable. Okay, and we maintain CPI, GDP, trade openness, exchange rate, as well as the constant term as our regresses in the estimation. So instead of fixed, we choose random. Okay, we choose random, and we have a number of options to determine the variance for the error term, or we have a number of options or technique used to estimate the error variance. We have the Swami Aurora, we have the Baltagi Chang, and we also have the LOB. So it depends on the assumptions that you have in the model. In this case, we are going to maintain the Swami Aurora technique or Swami Aurora approach to estimate the variance for the error. So click OK. We enlarge the results. So here we have the results for the random effects model. Remember, as I mentioned before this, in the Gradle, we use generalized least square to determine the random effects. And of course, we have 9 cross-sectional units because we have 9 countries and the time series length is 23 years. So the dependent variable is the number of tourist arrival, and just like in a fixed effects model, we have constant CPI, GDP, trade, and the exchange rate as our regresses. So here we have a number of important information for the regresses. We have the coefficient, standard error, Z value, and the P value. So we can identify that CPI. Yeah, if you can run the regression together with me, you can see that the CPI is not significant. Yeah, in explaining the number of tourist arrival, even at 10% significance level, while GDP, trade openness, as well as the exchange rate are significant in explaining the number of tourist arrival. So GDP and exchange rate are significant at 5% significance level, while trade openness is significant at 1% significance level. Since p-value is less than 0.01 for the trade, and p-value is between 0.05 and 0.01 for the GDP and the exchange rate. So apart from that, we can also see that the exchange rate is negatively related with the tourist arrival, while GDP and the trade openness are positively related with the number of tourist arrival. Remember, when we have positive relationship, it means when the independent variable increases, the dependent variable will move in a similar direction. It will increase as well. And conversely, when the independent variable decreases, the dependent variable will decrease or fall as well. So the negative sign shows the inverse relationship between our variables, between the dependent and the independent variable, where in this case, when the exchange rate increases, the number of tourist arrival will decrease. Okay, the number of tourist arrival will decrease. Of course, we have some key information for our model. We also have the mean dependent variable, sum squared, residual, log likelihood, Schwarz criterion, and down to Hannan-Quinn criterion. And here we have the between and within variances because we have both components. Okay, we have the between entity error, and we also have the within entity error when we conduct the random effects model. In so similar to fixed effects model, in a random effects model, the joint test. Okay, we have the joint test for the regresses. So this test is used to determine the joint significance for the independent variable in explaining the dependent variable. In our case, this joint test will help us to determine the joint significance for the macroeconomic factors in explaining the number of tourists arrivals. So we apply the Bruges Pagan test when we conduct the random effects. This Bruges Pagan test will help us to compare between well, this Bruges Pagan test has a null hypothesis which states that the variance of the unit specific error is equal to 0. So this is the null hypothesis for Bruges Pagan test. We have the asymptotic test statistic for chi-square that is equal to 104.575, and a p-value for this test is equal to or less than 0.01. So since the p-value is less than 0.01, we have to reject the null hypothesis. Okay, we have to reject the null hypothesis, which means that it is evident. Yeah, it is evident that the model has a significant differences across entity. So, in other words, the random effects is more appropriate than OLS because we have differences. Okay, we have significant differences across entities in the estimation. While the Horstman test, let me take a look if we have some question. Yeah, sorry, Dr. Siti, I forgot to click the share presentation. I am sorry for that one. So we're back again to our discussion. So this Hausman test is used to compare between random effects and fixed effects model. Remember, in a random effects model, we assume that the variation across entity to be random. In a fixed effects model, we assume that the variation across entity to be fixed. Yeah. So based on the Hausman test, the null hypothesis states that the GLS, generalized least square estimate, are consistent. So the null hypothesis states that it is better for us to use random effects than fixed effects because random effects will be consistent. The asymptotic test here based on chi-square is equal to 12.0175 with a p-value that is less than 5%. P-value is less than 0.01. So since p-value is less than 0.05, we have to reject the null hypothesis where the GLS estimates are consistent. In other words, compared to random effects, it is preferred for us to use the fixed effects model. Oleh kerana nilai P adalah rendah daripada 5%, kita terpaksa menolak hipotesis null yang mengandaikan bahawa estimation ataupun anggaran GLS adalah konsisten. Dalam erti kata yang lain, berdasarkan Hausman test, ujian Hausman, kita terpaksa ataupun kita perlu memilih fixed effects berbanding random effects kerana anggaran yang diperolehi daripada model GLS adalah tidak konsisten. Alright. So, additionally, we can also conduct some additional diagnostic tests, yeah, to determine the validity of our random effects. So, in order to conduct the diagnostic test, we click test, and then here we can identify or check the normality of our residual. Okay, we can check for the normality of our residual. So we can close the graph as well as the residual distribution table and straight to the summary. of our normality test. Here, test for normality of the residual states that the null hypothesis assume that the error is normally distributed. So the test statistic based on chi-square for the model is equal to 200.401 with a p-value that is less than 0.01. So since the p-value is less than 0.01, we have to reject the null hypothesis of normally distributed residual. In other words, we have to conclude that our model contain residual that are not normally distributed. So apart from the normality of the residual, we can also check for the autocorrelation. So same, just like fixed effects model, we wanted to test the randomness of the error term. Okay, the autocorrelation is used to test the randomness for the error term. In the fixed effects as well as in the random effects, we assume the error term to be random. We assume the error term to be not correlated. So the Woolridge test for autocorrelation in panel data has a null hypothesis which states that we have no first order autocorrelation in our model. So here, the test statistic based on F value is equal to 723.931 with a p-value that is less than 0.01. So we have to reject the null hypothesis of no first order autocorrelation and conclude that our model contains first order autocorrelation in the error term. So it means that our error term are non-random. They are correlated across time. As I mentioned before this is a sign that we have a misspecification in the model. It may happen because we fail to include some key variables as additional independent variable. So, autocorrelation berlaku boleh disebabkan oleh kegagalan kita dalam menentukan ataupun pembuli ubah lain yang signifikan dalam mempengaruhi pembuli ubah bersandar. So, oleh kerana kita gagal memasukkan maklumat tersebut ataupun pembuli ubah tersebut, maklumat bagi pembuli ubah yang gagal dimasukkan ini akan direkodkan ke dalam error term yang menyebabkan error term bagi model kita berkorelasi ataupun tidak rawak. So that is why we have autocorrelation issue, just like what we have in this example, just like what we have in this estimation. So let me check if we have question. All right, so far so good. Do you have any questions so far, everyone? So here we also have, let me check. We also have, tadi saya ada nampak Dr. Rosli, pakar dalam panel data. Dan kita juga ada Dr. Siti yang mahir dalam analisis econometric. So do you have any questions so far? So far, okay. All right. Thank you very much, Herniza. Okay. So, of course, apart from the autocorrelation, we can also check for the cross-sectional dependence. So, just like fixed effects, we also use Pasaran cross-sectional dependence, where the null hypothesis states that no cross-sectional dependence in the model, no contemporaneous correlation. The asymptotic test statistic here is equal to 8.9993 for the z value with a p-value that is equal or less than 0.01. So remember that this Pasaran cross-sectional dependence is to test whether the residual are correlated across entities. Yeah, it is an important assumption in random effects as well, because when the model contain cross-sectional dependence, it may lead to a bias in the estimation. And of course, in this case, we are also suffering from that contemporaneous correlation. So that's all for random effects model. I think we can take a break for 5 minutes before we continue with the pooled OLS. Noraini Yusuf, do you have any question? I haven't seen you for quite some time already. Wong, do you have any question? So Wong is one of my PhD student. Yeah, so far we managed to publish a paper, I believe last year, 2019. Yeah. So if I'm not mistaken, in that paper, we try to determine the influence of governance quality towards economic development. Oh, okay. Noraini, baru bersalin. So, Tahnia, Noraini, Tahnia, banyak-banyakkan ataupun cukup-cukupkan rehat. No wonder lama tidak dengar ya, Noraini. So in this session, any one of you are using panel data in your analysis? So dalam sisi ini adakah di antara kita yang menggunakan analisis panel data? So if I'm not mistaken, Wong will also be using this. Okay, he will also be using panel data in his thesis. And perhaps same goes to Noraini. So we continue our session. Let me present the screen before we continue, so that you're not going to miss anything on the things that I'm doing in order to run the analysis for static panel data. So yes, Juan Herneza, nice to meet you. So we have Wong. Wong asked on how we deal with the missing data. So if the number of missing data is not significant or not huge or not many, then you may try to omit the missing data and analyze the remaining information, because in a panel data this is actually not a major issue unless the number of missing data is huge. And apart from that, we can also try to use a different proxy for the variable. Okay, we can also use different proxy, okay, in order to represent the variable selected. For example, say that you have a huge missing data for gross domestic product, then you may try to use industrial production index or IPI, for example, as a proxy for economic development. So there are various approach that we can use, okay, to fix some issue, including the issue of missing data. All right. So say for example, based on the Bruges Pagan test, yeah, based on the Bruges Pagan test. Remember, this Bruges Pagan test is used to compare between the to compare between random effects model and pooled OLS. So say, for example, based on the Bruges Pagan test, okay, we identify that the differences across entity are not significant. Okay, say for example that the differences across entity are not significant. So in that case, instead of using the random effects model, we can simply conduct the pooled OLS in order to estimate the relationship between the variables. Yeah. For example, okay, say for example, we have conducted the Hausman test and it is identified that random effects is consistent, but based on the Bruges-Pagan test, we identify that pooled OLS is consistent. So in that case, we can simply run the pooled OLS in order to test or in order to estimate the relationship between the variables. So the pooled OLS is similar to the OLS for time series data. OLS is referred to the ordinary least square. It is the abbreviation for the ordinary least square. So in order to run the pooled OLS for panel data, we click or choose model and then simply choose the ordinary least square. We simply choose the OLS here. So of course, we have to determine the dependent variable, and based on the example that we have here, we are using the number of tourist arrival as the dependent variable. And we maintained what we have here in this particular box as our regressors. So click OK. Okay, click OK. Here we have the result for pooled OLS. And we have 9 cross-sectional unit with 23 years of time series information. dependent variable is the number of tourist arrival. So here, in this estimation, of course, we have a number of important information for the regresses. We have the coefficient, we have the standard error, we have the t ratio, and we also have the p-value. We can identify that the CPI is not significant, even at 10% significance level, while the GDP is significant at 5% significance level since the p-value is less than 0.05, while the trade openness and the exchange rate are both significant at 1% significance level since the p-value is less than 0.01. So we can also tell that the GDP and the trade openness are positively related with the number of tourist arrival, while the exchange rate here shows negative sign in the coefficient, which means that there is an inverse relationship between the exchange rate with the number of tourist arrival. And this is actually similar with the results that we obtain from both fixed effects and random effects model. Of course, we also have a number of important information for the model. And in order to test for diagnostic tests, simply click test. Here we can run or we can identify some diagnostic tests that we can choose from in order to determine the validity of our pooled OLS. We can run for the heteroskedasticity test. In this case, instead of group-wise, we also have the white test to determine whether our model is homoskedastic or heteroskedastic. So say that we choose the white test. Okay, close this heteroskedasticity test result, and we can directly go into the summary for the white test for heteroskedasticity. So the null hypothesis states that heteroskedasticity is not present. In other words, null hypothesis states that our model is homoskedastic. So andaian bagi ujian adalah model kita tidak mempunyai masalah heteroskedasticity, ataupun dalam arti kata yang lain, model yang kita gunakan adalah homoskedastic. So the test statistic based on LM test, Lagrange multiplier test, is equal to 52.828, while the p-value is less than 0.01. So unfortunately, since p-value is less than 0.01, we have to reject the null hypothesis for homoskedasticity model. In other words, we say that our model contains heteroskedasticity, where the variance across error term are not constant or varied across time. So apart from the heteroskedasticity test, we can also run for the normality of the residual. So we close the graph as well as the table for residual distribution. Here, test for normality for the residual. The null hypothesis states that the error is normally distributed. This is the null hypothesis for the normality test. The error is normally distributed. That is also an assumption that is important for a valid estimation. So the test statistic based on chi-square is equal to 742.761, and the p-value, or with the p-value that is less than 0.01 or less than 1%. So unfortunately, we have to reject the null hypothesis of a normally distributed residual. In other words, we conclude that our model contains residuals that are not normally distributed. Let me check if we have question. Okay, so far so good. All right. So apart from the normality test, we can also test for autocorrelation. Yeah, the autocorrelation in order to determine whether our error term are random or not. It is very important for the pool OLS to be or to have error term that is random. Yeah. So based on the Woolridge test for autocorrelation, the null hypothesis states that we don't have first order autocorrelation in the model, and the test statistic based on t value is equal to 68.4532 with a p value that is less than 0.01. So since p value is less than 0.01, we have to reject the null hypothesis of no first order autocorrelation. In other words, our model also suffers from the issue of autocorrelation. So this is the same issue that we have experienced when we conduct the fixed effect and the random effects for the panel data that we have here. And last but not least, we can also test for the cross-sectional dependence based on the Pasaran cross-sectional dependence test, where the null hypothesis states that our model is free from contemporaneous correlation. In other words, we have no cross-sectional dependence in the model. So the asymptotic test statistic based on z value is equal to 10.2198, and the p-value is less than 0.01. So since the p-value is less than 0.01, unfortunately, we have to reject the null hypothesis of no cross-sectional dependence. So when we reject the null hypothesis of no cross-sectional dependence, we have to we have to conclude that our model contains contemporaneous correlation. So remember, as I mentioned before this many times, when cross-sectional dependence occur in the model, it can lead to the bias in our estimation. So I think that is all for pooled OLS. So this pooled OLS, as I mentioned before this, is quite similar to the ordinary least square or OLS for time series analysis. Pretty much the same. In the pool OLS, the difference across entities are identified to be non-significant. So do you have any question before we end our session? Now it's 11:13. We start at 9. So roughly 2 hours and 15 minutes. And we are not going to continue with the dynamic panel data analysis. So this dynamic panel data analysis, is quite different than static panel data analysis, because in a dynamic panel data analysis, we have the lag value of the dependent variable that is used as the additional independent variable. Keep in mind, when you have an autocorrelation in the static panel data analysis, so when you have tried to log transform the variable, when you have added the time series information, or when you have added the cross-sectional information, but when you conduct the autocorrelation and it still persists, it may tell you, or it may be a sign that instead of conducting a dynamic, or instead of conducting a static panel data analysis, perhaps you may try to use the dynamic panel data instead. Yeah. So jika kita mengalami masalah autocorrelation, walaupun kita telah pun log transform ataupun mentransformasikan data kita dalam bentuk natural logarithm, Atau walaupun kita telah pun menambahkan maklumat data siri masa, kita telah pun mengembangkan cross-sectional information, we have added additional variables is we supposed to conduct the dynamic panel data analysis. It may be assigned, ya. So maksudnya di sini ini mungkin boleh menjadi satu petunjuk bahawa berbanding menggunakan data statik ataupun panel data statik, kita seharusnya menggunakan panel data analisis yang berbentuk dinamik. Ini hanyalah satu cadangan jika kita mengalami masalah autocorrelation pada static panel data analysis kita. But of course, autocorrelation can also happen in the static panel data model when you have missing variables, okay, missing key variables in the independent variables. And then, yeah, as I mentioned before this, we are not going to discuss the dynamic panel data analysis in this particular session. We will save this discussion for future workshop. Yeah, as a brief explanation, in a dynamic panel data analysis, we have various methods that we can use to estimate the dynamic panel data. Okay, the most popular will be the GMM, or generalized method of moments, based on Blundell and Bond and based on the Arellano Bond estimation. But we are not going to discuss further on these two estimations. We will save it for future discussion. As for now, I hope that all of you have understood or understand my explanation or our discussion on static panel data analysis. And if you have further question, feel free to contact me. And in order to see, in order to discuss the solution for the particular or specific questions that you have later on. All right, so we will try our best in order to address those questions later on. So do you have any question before we end the session and I leave it to Puan Elizabeth to to conclude the workshop? Do you have further question? Do you have additional questions before we end the session? Ada soalan-soalan sebelum kita menamatkan workshop kita pada hari ini? And I am sorry for all the weaknesses that we have in this session. For example, I forgot to click the presentation button, and then we have some audio issue before this due to internet connection problems. So as I mentioned before this, if you have any question, feel free to contact or feel free to email me. Yeah? Yes. Thank you very much. Welcome, Puan Herniza, Puan Noraini, and Encik Khairul Anwar. Yeah, hope to meet you again in the next workshop if we have another session after this. Yeah, it depends on the faculty to decide. Yes, thank you very much, Lo Ching Yi from PLUMS. Thank you very much, everyone. Thank you very much. We also have Puan Rafida here. So we have Norazilawati, we have Nurul Nazira, we have Wong, Lina. Thank you very much. So until we meet again next time. So I think leave the session to Puan Elizabeth.
Okay, thank you, Doctor.
Welcome, Puan.